Section 3.5 is on relations and functions. So a relation is any set of ordered pairs, and the x values of the ordered pairs, these are what's called the domain. And the y values are what's called the range. Now, a function is a special type of relation. So a function is a relation that assigns to each element x exactly one element y. The x values are called the domain still for a function. They're the input. Sometimes they're called the independent variable. And the y values, or sometimes they're called the f of x values, are the range. They're the output of the function, and sometimes they're called the dependent variable. So there's a lot of terminology here. Really, a lot of the stuff is just stuff that we've already seen. They're just calling it different things. So functions can be used to express equations. They can be used to express graphs, tables, and then ordered pairs. So all of these things are mathematical things that we've seen before. Now we're just calling them functions, and they have slightly different terminology, slightly different notation, but most of the stuff is things that we've seen before. So number 1 and 2 say, find the domain and range of the following relations, then determine if the relation is in fact a function. So like we said, the domain, these are the x values of these ordered pairs. And the x values always come first, so this is going to be -2, 3, 5, and you'll see that we have -2 twice here, but I'm only going to write it once. So I don't need to write -2 twice, just once. And then my range is the y values. And I like to put it in ascending order, so start with the lowest first. It's kind of a good habit to get into. So the -7 is the lowest y value, then 5, then 6, then 10. So that is the domain and the range. Then it wants us to determine if it's really a function. So the most common way of doing this is to create a mapping. And I'm going to put my domain values here and my range values here. And then if I look at my ordered pairs, -2, the x value of -2 is associated with the y value of 5. So in my mapping, I'm going to draw a line from -2 to 5. And then 3 goes to 6, 5 goes to 10, and then -2 also goes to -7. Now, in order to be a function, if we look back at the definition, a function is a relation that assigns to each element x exactly one element y. And that is not the case here, because if you look at the -2, that's getting mapped to 2 different y values. So we can't have that. So no, this is not a function. Let's do number 2. My domain is 0, 2, 4, and 6. My range is 3, 5, and 7. So then to determine if this is actually a function or not, I want to make a mapping. So I've got 0, 2, 4, and 6, and then 3, 5, and 7. So 0 gets mapped to 3, 2 gets mapped to 5, 4 gets mapped to 7, and 6 gets mapped to 3. Now, in order for this to be a function, again, if we look back at the definition, each element x needs to be mapped, or can only be mapped to exactly one element y. And that is the case here. If you look at all of our x values, they're each only being mapped to one y value. So there's only one line going to each of these x values. With the y, we have 2 lines going to 3, but we don't really care about the y values if there's more than one line being drawn to that. So this would be, yes, it's a function. So you can't have more than one line going to an x value, but you can have more than one line going to a y value. And we'll talk more about that, or why that's important for functions, a little bit later on.